So, hi class again. So I decided to record a short video on logistic equation, logistic core, logistic differential equation. Um, and yeah, we discussed Malthusian population growth model, and now let's talk about uh, let's talk about logistic equation. So we can write this differential equation as in the following way: dx dt equals 2kx a minus x. Okay. Remember, in the Malthusian case, we didn't have that part. Okay, we didn't have that part. That meant that we had an exponential growth of population, and at some point we will have so many people and on Earth that there will not be place anymore for everybody. So we have this little addition here. But now you see we have a differential equation, and our great task is to solve it. Okay, so this is dx. So as you may already noticed, this is separable differential equation. Okay, so let's separate it. We can rewrite this equation in this form. We can put this here, x a minus x. So we moved it here, basically divided by x a minus by x a minus x. And here we will have k dt. Okay, k dt. Now let's do a further step. But as you already know, we should integrate both sides here since it's a separable differential equation. But this part really could worry us. So we need to simplify it in a way that it becomes kind of sum of equations, so we can separate the integrals. Okay, so how we can simplify this part, specifically how we can simplify, let's call it the equation, let's call it this equation 2, and this was equation 1. Okay, how we can simplify this part, specifically x a minus x. Okay, so first thing we can do is the following: we can multiply and divide by a, so it will change nothing, right? So it's just a divided by a is 1. Okay, so then it becomes a divided by x a minus x, and all this stuff multiplied by a. Sorry, 1 divided 1 over a. Okay, so now we should do another algebraic trick. We can add and subtract, or subtract and add x to the numerator, because nothing will change, right? So as you will see here, we will have denominator does not change, a minus x. Okay, and then we have again a here and a, and we are subtracting and then adding, right? So it will change nothing here, it will disappear. So then again multiply. So now what we can do an extra step, and we can just basically separate it, right? So we will have here a divided by x a minus x, okay, minus x, a minus x, and plus x, a minus x, and all this stuff we are multiplying by again 1 divided by a. So next step, we can do the following. We can just put this together. So we have common denominator, x, a minus x, right? And since we have a common denominator here, we'll have a minus x. And here, we can put this in the following way. Actually, it will disappear, right? So we will have here a divided by a minus x, again multiplied by. And here, good news is that this will also cancel. And then we'll have 1 divided by x plus 1 divided a minus x, and all this thing multiplied by 1 divided by a, right? So this is a really good thing, because now instead of multiplication here, we have separately, so we can split the integrals, okay? So let me do the following thing. Let me rewrite whole equation. So we want to integrate now 1 divided by, or let's split it, so nothing will change here, a minus x, okay, or let's leave it as it is, so some changes, not to confuse you. And here we have 1 divided by a minus x, and this whole thing multiplied by 1 over a dx equals to k dt, okay? I hope I'm not missing anything from you. So now we can integrate, and here is also we are integrating right-hand side. And now, as you see, the 1 over a is a constant, and we can now like split this integral. So take the integral of this part and then take the integral of this part, right? So this part is okay, right? This will be ln x, okay, plus some constant, and then we will reflect it on the other side. But the problem is here. So how we take the integral of this? So we need to use a substitution trick, rule of substitution. So okay, let's firstly integrate this part. So what will be integral of 1a minus x dx, right? So this will be, let's denote a minus x by u, okay? U is a minus x, okay? So du will be du dx. So if we take the derivative of u with regards to x, then we will have here minus 1, right? So then dx will be minus du, okay? So now we have everything basically to integrate this function. So we denote a minus x denoted by u, okay, this part, then it will becomes u. And here dx is just minus du, right? So just to write it more compactly, I will write minus sign here, and here we have 1 over u du. And it's now easy to integrate. So this minus sign will go because it's a constant, minus 1. So outside of integral, and here, what is the integral of 1 over u is ln u, okay? So we know what is u, so we'll have minus ln u, right? Uh, minus L instead of U, we will just put A minus X. Okay. So we have this equation. Now integration. Now we just put the whole stuff here. So what is integral of 1 over x is ln x. Then here we have what is integral of this part, what we just did. So we will have minus ln a minus x, right? And all this thing multiplied by 1 over a. So this we have here. And what is integral of k dt? So we k will have kt kt, k is a constant, plus some c, let's call it c0. Okay. So we can do further trick. So we will have ln x. So but let's use a rule of logarithm. So what is ln x minus ln a minus x? So it will become x divided by x, a minus x. Okay. So since logarithm is defined when actually this part is positive, we can't take the logarithm of negative numbers. So let's put the modulus here, right? The absolute value. So it will be mathematically then correct. Then we will have here a, so we multiply here both sides by a, then it will becomes kt a, right? And then this becomes a multiplied by c0, okay? Then we exponentiate both sides. So raise e to the power of this and also e to the power of this. And then we will get x minus a minus x equals to e to the power of k t a multiplied by e to the power of a c 0. Okay. And then we can denote it. This is just a constant, so it will be e, like we can put this c here. This whole thing is another constant. Like we can denote this as a c, big C. Let's call it big C. And then we will have a k t a. Okay. Now let me rewrite this whole stuff. Whole equation. So compactly. And then we can continue. So what we got the following step, right? X, a minus x equals to c multiplied by e to the power of a, k, t. Okay. Now, next step, what we want to do is that we want to find this like the initial initial conditions, just to define C. Okay. So let's say that initial condition for t is t0. Okay. And then for x is x0. Okay. Then the next step will be just to put this everything in terms of x0. Then we will have here x0 divided by a minus x0 again equals to c, okay, e to the power of a, k, and here we have t0, okay, because we defined this in this way. Now we can define, can we get c from here, from this equation? So c will be x0 basically divided by a minus x0, and then instead of dividing this both, okay, we divide both sides by this, okay, and this will come here. But if we change the sign of the power, then it will come here, right? You will get minus a k t0. So now we can plug this whole initial condition to our equation here, okay, specifically in C, okay. So we'll have a minus x equals 2 x0, right? X0, here we are. Yeah, here we are. X0, a minus x0. Then here we'll have e to the power of minus a k t0, and here we don't forget we have a minus sign, and all these things. So it was c, now we are multiplying by e to the power of a k t. Okay, then what we'll get here, so we can just sum this, right? We sum this because these are the powers. So, and then when we sum and put ak out of the parentheses, so we will get x0, a minus x0, and here we will have e to the power of ak t minus t0, okay? Because it's the power rule, what we have here. So just to rewrite this whole thing, so what we have here, x, a minus x equals to x0, a minus x0. Then here we'll have e to the power of ak t minus t0, okay? Okay, now we want to solve for x, but, you know, it's like a really makes me a little bit tired, this really kind of boring stuff. And so let me denote it by b so I don't write it again and again, okay? So now what we can do, multiply, so let's denote this part by b, and then multiply both sides by a minus x, okay? So here we will have x0 multiplied by a minus x, okay, divided by a minus x0, okay, and then multiply this whole thing by b. So this is our b, okay? Don't forget about it. Now we can do another algebraic trick, and we can divide everything by x. Okay, so this part x by x over x is 1. So 1 equals 2. Then here we will have x0 um, multiplied by a minus x, and this divided by x, and this divided by a minus x0, okay, and this multiplied by b, okay. So we can just put this b to this side. So we divide both sides by b. So we'll have here 1 over b. And here, what we can do to just multiply was firstly, so we'll have x0 a minus x0 x divided by x, and divided all this part by a minus x0. Okay, so we move the b to the other side, okay? So when we divide this, we'll get here, and actually, since they are division, so we can multiply both sides now by a minus x0, okay? So we'll have here a minus x0 divided by b, and here we will get, so x0 divided x0a divided by x. So we are splitting this x0 multiplied by a over x, and here we get minus x0, right? x0x divided by x will be, in this case, x0. Okay. So then we it simplify it further. So we write a minus x0 divided by b plus x 0 equals to x0 x0 a divided by x. Okay. So now we can multiply both sides by x. So we will get x multiplied by a minus x0 over b plus, so this x0 here we have x, right? And then we will have x0a. Okay. So now we can divide both sides by this, okay, by this part, and we will get x equals to x0a divided by a minus x0 over b, but actually, instead of over b, we can write that b to the power of minus 1, okay? B to the power of minus 1. And then, so we have here plus x0, okay? So now we have everything to write the solution, final solution. We can write it in this way. a a, so let's put the constant in front, x0 divided by a minus x0, okay? And what was b, our nice b? B was, if you remember, but if not, it's okay. Let's find the b. It was our b, okay? This was our b. So now we should write this here. So instead of b, we have b minus to the power of -1. So it will become e to the power of minus a. So since it's -1, right, it will be minus a k, okay, t minus t0, okay, minus t0, okay, this is in the power, and then plus x0, okay. Voila. Okay, so this is the solution, okay. Now, regarding the interpretation, we will do it tomorrow. So how we can interpret the coefficients, etc. Okay. Yeah, I hope you enjoyed this beauty and see you tomorrow.